Hello, what we're going to do today is continue with our laws of exponents to simplify monomial expressions, one term. We are revisiting the fact that what we're doing is dealing all with multiplication, recalling the difference between adding and subtracting terms where we need the same term to the same power, the same variable to the same power. When it comes to multiplying terms, we can multiply whatever we want as long as we're following certain laws. In the previous set of notes, we went over the laws of the zero exponent and laws of negative exponents. So today we're going to get into the next law of exponents, which deals with multiplication. So we're going to get into the law of exponents that deal with multiplying two terms that have the same base. Okay, so before we do that, again, we dip into prior knowledge. So for this piece of new information, the prior knowledge we have to get good at, again, is the meaning of exponents, knowing that 4 to the third power is, of course, 4 times 4 times 4. X to the sixth power means we're multiplying x by itself 6 times. X times x times x times x times x times x. That's the sixth power, understanding that that's what exponents mean. We also need to remember the commutative property of multiplication. So if I had this expression, 3x times 4, I can rearrange all those terms because all that's happening here is multiplication. I'm only multiplying these things. Okay, so I'm only multiplying 3 times x times 4. Which means I can rewrite this expression as 3 times 4 times x. And then I can multiply 3 times 4 to give me 12x. So I have to recall that the commutative property works. And again, I need to recall or bring back to memory that we don't need like terms in order to multiply. So I have to remember that. I only need like terms if I'm adding or subtracting. I don't need like terms if I'm multiplying. So if we can remember that, we're going to be good to go with these laws of exponents, especially when it comes to multiplying. So let's get into the new notes. For the next law of multiplication, we're dealing with the multiplying law, which states this. If we are multiplying two numbers that have the same base, okay, this is called the base, this is called the exponent, this is called the base, this is called the exponent. If we're multiplying two numbers that have the same base, that means we keep the base and add the exponents. So whenever we are multiplying two of the same bases, we keep the base and we add the exponents. Okay, so we keep the base, add the exponents. That's what this law states. So that is the law of exponents dealing with multiplying the same base. So now let's do some examples where we put that law into practice and see how it works out. So we'll start with the first example. If I had the expression 4 to the third power times 4 to the seventh power, how do I simplify that expression? I have the same base, those 4's. So I'm multiplying two numbers with the same base, and that's what the law of exponents gives me. If I multiply two numbers that have the same base, that means I keep the base and add the exponents. So that means I'm going to keep that base of 4, but I'm going to raise it to the 3 plus 7. I'm adding the exponents. So that's what the law states, and that's how I put it into practice. So when we simplify that, we have 4 to the 10th power. Which if we want to, we can multiply that all the way out and get a really, really big number, but there's no need to do that. We can just leave it as 4 to the 10th power. Since this is so huge, we'll leave it there. If it's a smaller number, we can evaluate it. But that's just I just want to demonstrate that law of exponents. So let's test our memory with this new law and see what we can recall from previous lessons. Let's do another example. So let's say I had this expression. 8 to the fourth power times 8 to the negative sixth power. So what's happening is we're using this new law of exponents. We're multiplying two numbers that have the same base. And the law states that if I'm multiplying two numbers that have the same base, I keep the base and add the exponent. That's what the law states. So if I have 8 to the 4th times 8 to the negative 6th, I'm going to keep that base of 8. I'm going to add those exponents. So I have 4 plus negative 6. That means I have 8 to the negative 2 power. So now what we need to do is recall, are there any other laws of exponents we can use in this expression? And of course, from previous knowledge, remembering from the other bit of notes, that law of negative exponents. Do you remember the law of negative exponents? If I have a base to a negative power, I keep it positive, I just move that base to the bottom, oops, and then the power becomes positive. So I keep the base positive, I just move it to the bottom. So if I have 8 to the negative 2, what that means is I have 1 over 8 to the positive 2. It doesn't mean it's negative, it just means it's really, really small. And since I have a number that I can easily evaluate, 8 to the 2nd power, go ahead and do it. Since it's easy to do it, we're going to go ahead and do it. That's 1 over 8 to the 2nd power, 64. So I'm using the new law of exponents that we just learned today, where we are multiplying two numbers of the same base. And then once I do that, I'm using the law that we covered yesterday, which is the law of negative exponents. And yes, you can apply multiple laws to simplifying any terms. So let's do a few more examples, and we'll see how this multiplication law is used with just itself sometimes, or with other laws. Knowing how monomials work. So here's another example. What if I got away from dealing with numbers? What if I went into variables? So I have x to the 3rd power times x to the 4th power. Even though they're variables, it's still the same base. I'm still multiplying two numbers that have the same base. And if I'm multiplying two numbers that have the same base, there's my law. When I multiply two numbers that have the same base, I keep the base, add the exponents. So in this case, I'm going to keep that base of x. I'm going to add the exponents, 3 plus 4. So that means I have x to the 7th power. And since I have this expression, x to the 7th power, and there are no other laws of exponents I can apply, that's it. I'm simplified. So there is my simplified expression. X to the 7th power. All right, let's do something that might be a little bit trickier. So in this next example, we move up in levels of complication. So we're going to simplify this expression now. We have to recall what's happening between all of these numbers. What's happening between all of these numbers is multiplication. 3a to the 4th power means I'm multiplying 3 times a to the 4th power times a. So I have to remember that that's exactly what's going on. So I'm looking at 3 times a to the 4th times a. Okay? But now the question is, what is the exponent to this a? What is the exponent that's up there? So we're going to have to figure that out, or know that fact. If it's just an a, how many times are we multiplying it by itself? This means what we're looking at is 3 times a to the 4th times a to what power? Some of you might say, well, it could be 0. It's not 0. Remember, anything to the 0 power is the number 1. This a is here. So the exponent is not 0. The exponent must be 1. So we have to know that too. Remember that 1 is a ninja. You don't see that 1 here, but it's there. Okay, so it's a to the 1 power, or a to the 1st power. Once we know that, we're then able to apply our new law of exponents. I'm multiplying a number of the same base. And remember, for multiplying two numbers that have the same base, keep the base, add the exponents. Excuse me. So what's happening up here? We have 3 times, that's not going to change. However, we have a to the 4 plus 1 now. 3 times a to the 4 plus 1. All right, because that exponent for the original a was actually a 1. So we have 3 times a to the 5th. And since that's all multiplication, we just scrunch that together. Call it 3a to the 5th. And since there are no more laws of exponents to apply, we are simplified. Okay, so the trick with this one, there are 2 tricks. Knowing that all of this is multiplication that's happening. This is all multiplication, that's the first trick. The second trick is knowing that the exponent to this is the 1, is that ninja 1. You may not see it, but it's there. It's like a ninja. All right, so that's the trick to that one. Let's do something a little bit more complicated. I'll use a new sheet. I want you to be able to recognize multiplication when you see it. So here, let's work on this example. If we have negative 2x squared, and then it's going to be multiplied by 4x to the 3rd power, what's happening when we want to simplify this? What we need to see in this example, that what's happening all over this thing? What is the operation that we're using throughout this entire expression? Is multiplication. You have to remember that we are simply multiplying through the entire thing. This is all multiplication. So this is saying negative 2 times x squared times 4 times x to the 3rd power. Just recognizing that the whole thing is multiplication. And since the whole thing is multiplication, we can use the commutative property of multiplication. You can multiply it in any order. So let's put it closer together. We have our negative 2 times our 4. We can multiply it in any order. Times our x squared times our x to the 3rd power. So we can use the commutative property of multiplication. And now what we can do is use our law, okay? Negative 2 times 4 is what you think it is. It's negative 8. However, when we're looking at x squared times x to the 3rd power, we have that new law of exponents we get to use. All right, so here we're implementing that new law of exponents. If I multiply 2 numbers that have the same base, I keep the base. I add the exponents. Okay, so again, when you're looking at this, negative 2 times 4. If you get confused on what to do with it, say it out loud. You just say it out loud. Negative 2 times 4 is negative 8. There's no tricks, there's no laws. It's negative 8. But now we have x to the 2 plus 3. So now we're using that law of exponents. So we have negative 8 times x to the 5th power. And since that is all multiplication, we can simply scrunch that together and have our simplified expression. Negative 8 x to the 5th. So there's our simplified expression. All right, so we're using the law of exponents. Again, recognizing that all of this was multiplication. And since multiplication is commutative, we can rearrange it. And once we rearrange it, we use the law of exponents for the same bases. And we just say negative 2 times 4 out loud. And that's all that example entails. So let's do something a little bit more complicated. The next example looks a bit crazier. Let's say we have 3x squared y to the 3rd, another variable, times 5xy to the negative 3. So here's this example. Let's simplify this expression. looking at this expression, again, it's important to understand what is happening to all of these variables and numbers. What's going on between them? What operation are we using? It's just multiplication. And since it's just multiplication, we know we can use the commutative property. So since this is all multiplication, we have 3 times x squared times y to the third times 5 times x times y to the negative 3. And since it's all multiplication, we can rearrange it. So let's put our numbers together. We have our 3 and our 5, so we have 3 times 5. Let's put our x's close to one another. We have x squared, we also have x. Let's put our y's close to one another. We have y to the third, we have y to the negative 3. So we've used the commutative property now, and now all we need to do is either multiply 2 numbers or use that new law of exponents. Remembering that the law of exponents states that when you are multiplying 2 numbers that have the same base, you keep the base. You add the exponents. So when we're looking at 3 times 5, that of course is 15. But then we have x squared times x. So let's remember, what is the exponent here? What's that number up here? What's the number's going to be up there? It's the invisible 1. Okay, so we're dealing with that law of exponents. We're looking at x to the 2 plus 1. And then the exponents for our y. Y to the 3 plus negative 3. And so we're using that law of exponents when it comes to multiplication. So we have 15 times x to the third power. And then we have y to the 3 plus negative 3 is, of course, 0. So we have our expression here. And the question is, are there any other laws of exponents we can use? The answer is, of course. Remembering the law of zero exponents. A to the 0 equals 1. Anything raised to the 0 power is 1. So technically you're looking at 15x to the third power times 1, which anything times 1 is itself multiplicative identity property. So you have 15x to the third power. No more laws of exponents can be used to that expression. There's our simplified expression. So again, look at where we started from. This crazy looking expression. Everything is multiplication, so everything is commutative. And when we rearrange our terms, we can use our law of exponents. And we remember that the exponent to this little term here is the 1 first power. And so we get x to the third power, and then we have our 0 exponent law to have our simplified expression. All right, let's do something a little bit more complicated. Keep you on your toes. Wait till you see the test. So let's say we have negative m squared times 4r to the third power times 12r to the negative fourth power times 5m. We're going to simplify this expression. So let's take a look at this monster. And again, we begin. What is happening between all of these terms? What's going on? What operations are we using? In this case, again, it's all multiplication. So what's happening here? We have this negative m to the second power. What's being raised to the second power? Just the m. Is the negative being raised to the second power? No. So the negative is kind of operating on its own. That means we can write it like this. It's going to be kind of funny looking, but we can write it like this. It's negative times m to the second power times 4 times r to the third power. Remember, this whole thing is multiplication. And then we have times 12. And then times r to the negative 4. Changing colors is kind of hard. Times 5 and times m. So recognizing that all of this is multiplication. And also knowing that that negative sign is operating on its own. It's not being included in the raising to the second power. So you have to be able to recognize that. So now what are we going to do? We're going to rearrange everything, use the commutative property to put all of our numbers together, our variables together. So we have that negative that's out there, times, we can write the 4 next, times the 12 next, times the 5 next. Because of the commutative property, we can multiply in any order. Then we can multiply our m's together. We have an m squared here. We also have an m over there. What's the exponent? The exponent is 1. Times our r to the 3rd power, times our r to the negative 4th power. So we're just using the commutative property. Now what we can do is just start multiplying out or use the law of exponents. And the law of exponents states that when you multiply two numbers that have the same base, you keep that base, you add the exponents. So what do we do with this mess? Just multiply everything out. Okay, you can do it a bunch of ways. 4 times 5 is 20, 20 times 12 is 240. 4 times 12 is 48, 40 times 5, 240. Either way, you just come up with 240. But don't forget that negative sign. So it's going to be a negative 240. And then we have the law of exponents dealing with the m's. Okay, so m to the 2 plus 1 is 3. And then we have the r's. R to the 3 plus negative 4. What's 3 plus negative 4? Negative 1. So we have this expression now. Do you see any other laws of exponents we can use from here? I do. We have a negative exponent. Remember that law. The law of negative exponents states if you have a negative exponent on top, the term moves to the bottom and the exponent becomes positive. That means this r to the negative 1 moves to the bottom and the whole thing becomes positive. So we have the negative 240 stays, the m to the 3rd power stays, it's the r to the 1st power that moves to the bottom. So what we have here, we're not quite done. What we have here is when the r to the negative 1 moves to the bottom, becomes a positive 1, do we need that 1 anymore? No, that ninja goes back to being invisible. It doesn't want to be seen when it doesn't want to be seen. So the ninja goes back to being invisible. We can simplify it even further. R to the 1st power is simply r. We don't need that to the 1st power. And we have our simplified expression. And that's how we use our new law of exponents. So you can see everything builds upon itself. We have old stuff from yesterday. We have new stuff from today. Tomorrow we'll learn even more. Okay, so there are more laws of exponents still to come, but this is it for now. We'll get practice on this and become real good. So I'll see you for the next lesson.